Hello everybody, this is the notes for the last week of school. Super. I'm going to cruise through the first two parts. Really want to focus in on using the trig functions in the unit circle. So let's get to it. Unit circle, it's a circle centered on the origin. When we look at this picture here, we got our x-axis, got our y-axis. The circle is centered at the origin. It has a radius of 1. It's the unit circle. Okay, how we use this. Let's talk about degrees. We always start at the positive x-axis. This is our 0 degree mark. Go up to the y-axis, 90 degrees, 180 degrees. It's just how much we're rotating around the origin, around the circle. Down here at the negative y-axis, 270, and we go back around 360 degrees. All right, we can keep on going, but those are the main angles. Now, it is a circle with a radius of 1. The circumference of the circle is 2 pi times the radius. So 2 pi times 1 is just 2 pi. That gives us the idea of going all the way around in radians instead of degrees. My board keeps on freezing here. So we're going to start with 0 radians all the way around, not degrees anymore, 2 pi radians. Okay, so the definition of a radian, just to kind of clear that up, I don't know how clear it's going to be, but this is what the definition of a radian is. It is the angle measurement that intercepts an arc, so just this part of the circle, that is the same length as the radius. So 1 radian is, I'm trying to jog my memory, it's like 57, 59 degrees, somewhere in that ballpark. But the angle that intercepts an arc the same length as the radius, so an arc of length 1. That's what 1 radian is. But when we go all the way around the circle, 2 pi radians. So if we start at the positive x-axis and only go halfway around, half of 2 pi is 1 pi. We only do half of that, that's up here at 90 degrees, that's half of a pi, which is pi over 2. And we can keep on going around breaking up these fractions. So 30 degrees, if we take 180 and divide it by 6, you get 30. So we're going to take pi, which is the same as 180 as far as the amount of rotation. We take 180 divided by 6, you get 30 degrees. So pi over 6 is right here. That's a 30 degree angle of rotation. So from 0 up to here, 30 degrees, but we call it pi over 6. This angle right here is halfway between 0 and pi over 2. So half of a half is a quarter, so there's pi over 4. We go from 30 degrees, we go another 30 degrees, we're up here at 60. That is 2 of those pi over 6's, so we get pi over 3. And you keep on going. All right, so now that's your radian measurements. We can go all the way around. If you want to see what all those angles are, because you don't have your unit circle from when we were in school, just Google it. There are millions of images of a unit circle with radian measurements. Okay, converting between radians and degrees. So you can kind of do this for certain angles. These are the main ones. But we also have, and that's kind of why I put this picture in here, but we also have this proportion. This is the way I like to set it up, but pi radians is to 180 degrees as what do you know and what don't you know. So just as a real quick example, I want to know what 120 degrees is in radians. So I'm going to go pi over 180 to equal, I don't know the radians, but I know it is 120 degrees. Okay, radian over degree. And so you can just cross multiply, solve for x, and clean up that fraction. Just to answer the question, 120 degrees is 2 pi over 3 radians. Okay, so we can do that. Depending on what you're given, sometimes you'll be given a radian, so like 2 pi over 5, and you want to know what that is in degrees? Pi is 180 degrees. That is our main thing to say, here's our conversion. So if pi is 180 degrees, 2 pi over 5 is 2 times 180 over 5. And whatever that ends up being. But that's the idea. Okay. trig functions, dealing with the unit circle. This is what I really wanted to get to. All right, so we all know our trig functions, sine, cosine, tangent. We use SOHCAHTOA. We're still going to use that. Oops, that's an A. Okay, so if I want to take the sine of, let's go 2 pi over 3, and I want to know what that is. First, we got to find our angle on the unit circle. So I just talked about 2 pi over 3. That is 120 degrees. We always start here at the positive x-axis. That's our 0 mark. 2 pi over 3, that's 120 degrees. So there's 90. We got to go another 30. So we're talking about this point right here. All right. On the unit circle, we find our angle. We always drop a perpendicular to the x-axis. Always perpendicular to the x-axis. It doesn't matter where you're at. Always perpendicular to the x-axis. And what that does is it creates a right triangle. All right, this acute angle right here at the origin, that is called our reference angle. So this was 120 degrees to get to here, 2 pi over 3. We went from 90, we went another 30 degrees more. So what that means is this reference angle right here is 60 degrees to get down to this 180. From 120 to 180, you got to go 60. But this is our reference angle. Okay, so that's going to be the one that we use in the right triangle when we talk about dealing with these trig functions. So the sine is the opposite over hypotenuse. The hypotenuse is always 1. It's the radius of the circle. It's a unit circle, so it's got a radius of 1. Now, with a hypotenuse of 1, this is where these 30, 60, 90 ratios and the 45, 45, 90 ratios come into play. You need to know those triangles. So let me give them to you real quick. In a 30, 60, 90, there's our 90, there's our 60. If that's 1, shorter leg is going to be a half. The longer leg is going to be root 3 over 2. In a 45, 45, 90 triangle, hypotenuse is 1. Each leg is root 2 over 2. Okay, back to our unit circle. We're trying to figure out the sine of 2 pi over 3. So our reference angle is always at the origin, dealing with the x-axis. So that's this one. It's a 60 degree angle. So basically it's a 30, 60, 90 triangle, hypotenuse 1. This is 1/2. I'm going to talk more about this in a second. This longer leg up here is root 3 over 2. Okay, to finish our problem, our reference angle is right here. That's the one we're going to use for our sine function. Opposite, root 3 over 2, divided by the hypotenuse. Square root 3 over 2, when we divide by 1, it doesn't really do anything. There is our sine function. Okay, now, next problem is going to be cosine. And we'll just use the same angle, 2 pi over 3. Again, going through the whole process, start at 0, rotate around. There's our angle, 2 pi over 3. We drop the perpendicular to the x-axis. Now the cosine, that's adjacent over hypotenuse. We know the hypotenuse is 1. We still have our reference angle here at the origin. Cosine is the adjacent. That's just 1/2. But here's where you got to be careful. No matter where your angle is, you always need to be thinking about the x-axis and the y-axis. When we go from the origin and go in this direction, so this adjacent side right here, we're going in the negative x direction. This is not a positive 1/2, it is really a negative 1/2. All right, so when we talk about cosine of 2 pi over 3, we get this right triangle. We're using this as our reference angle. Cosine is the adjacent. Negative 1/2 divided by the hypotenuse, so over 1, that's it. There's that answer, negative 1/2. Okay, so that is the idea. Let me change colors of pens here just to talk about a different solution, basically a different answer. If we went down here to this angle, trying to do my math real quick here, that is 5 pi over 3. Oops, 5 pi over 3. Okay, so if I want to know the, let's go sine of this angle, 5 pi over 3. Okay, we find our angle, 5 pi over 3, always go perpendicular to the x-axis. When we connect that point to the origin, that's creating our right triangle. Always at the origin is our reference angle. All right, we're talking about sine. So, again, we had to go 30 degrees from here. So, dealing with complementary angles, if this is 30, that means this one is 60. So we're dealing with a 30, 60, 90 triangle. Got to use these ratios up here. Hypotenuse is 1 because that's the radius of the circle. This is 1/2. Again, pay attention to the coordinate grid. From the origin, we're going in the positive x direction. This longer leg of the 30, 60, 90 triangle is going to be a root 3 over 2. However, we are going in the negative y direction. So, reference angle, we're talking about sine function, opposite over hypotenuse. Divided by 1 is not going to do anything, so negative root 3 over 2. All right, that is it. I hope this is helpful for you. I hope you enjoy your last week of this weird school, and I hope you all have a fantastic summer. Stay safe, stay healthy.